Hi, welcome to Algebra 2, distance learning. I hope that everyone is doing well, is safe, and I understand that math at a distance is a concern to some of you. Fortunately, we're working on trigonometry right now, which is fairly concrete. It's easy to master. It's also very important for your geometry, so make sure that you take time to memorize the formulas. If you've memorized them, things will go much better. It will stick in your head. I've made some packets for you. I've written most of what I'm going to say today in those. Make sure you refer to those as often as you need to. I am currently creating a video here for section 8.2. Okay, there will be a follow-up for 8.3 and 8.4. I'm going to combine those together. All right, so let's just start real quickly here. We're going to start with our trigonometry. Remember, we talked about transcendental functions. We learned the exponential function and the logarithmic function. So this is our third transcendental function as we're talking about trigonometric functions. Again, this is in your notes, but the mnemonic, the thing that's going to help you remember, is SOHCAHTOA. I'm going to fix that because it looks like a T instead of a C. Okay, SOHCAHTOA, an old Indian greeting. If you remember that, it's going to help you. Okay, S stands for sine, C stands for cosine, and T stands for tangent. Now, if you'll take a second look at your calculators, you'll see that there is a button that says SIN. Now, we're not sinning. This is the abbreviation, the shortcut for sine. Okay, the abbreviation for cosine is COS. You'll also see a button for that. And the abbreviation for tangent is simply TAN. We need to refer to them by these names, sine, cosine, and tangent. Now, SOHCAHTOA, the trigonometric functions, only work for right triangles. Okay, that's important to keep in mind, right triangles. In a right triangle, the side that's opposite the right angle is the hypotenuse. One of the legs, depending on our frame of reference, that's the section you just looked at. If my frame of reference down here, now we're going to use theta. It's a Greek letter now instead of A's and B's like you saw before. But if this is my reference angle, then the leg here is my adjacent side. We learned this a few weeks ago. And the one, if I go across the triangle, is my opposite side. All right? So notice here the letters OH, AH, and OA. These are going to stand O for opposite, H for hypotenuse, A is adjacent, and H again is hypotenuse. Again, we see an O for opposite and an A for adjacent. So when I work with the sine, I see O and H. That's going to give me the ratio of the opposite over the hypotenuse. For cosine, then, the ratio is going to be the adjacent side over the hypotenuse. And for tangent, we will have the opposite side over the adjacent side. Okay, so these are ratios in the right triangle. For instance, if I have a 45-degree angle here, the ratio of the opposite side to the adjacent side will always be the same. So we will see that the sine of a 45-degree angle, whether it's in a little bitty triangle or whether it's in a very large right triangle, as long as the angle is the same, the sine ratio will be the same. It will give us the same value. Okay, that's going to be important to realize later on. We'll talk about it more next year since we're kind of being handicapped just a little bit here. But for now, that kind of gives you a quick idea. All right, now the Pythagorean Theorem, we're going to have to talk about that real quickly before we go here. You should already know from last year is a squared plus b squared equals c squared, where c always represents the hypotenuse. A is one leg and B is the other leg. Remember, depending on which one we want to solve for, we want it isolated. Okay, so you should know how to do this. If not, you have examples in your book. So back to this here. if I am given then that this side is 6 and this is 8, and I want to find the hypotenuse, of course I can say that 6 squared plus 8 squared is equal to c squared, or 36 plus 64 is c squared, which gives me 100 is c squared. Taking the square root of both sides, I find that c is 10. Okay, so sometimes you'll have to find the third side. There may be an x there. And so you know how to do that by using the Pythagorean theorem. Once we have that, depending on my angle, if this is my reference angle down here at theta, then the sine of theta will be equal to the opposite, which is 6, over the hypotenuse, which is 10. Now this is a fraction, so what do we always do to fractions? We want to make sure we reduce it, so this will be 3/5. All right. The cosine value will be the adjacent, which is right here because this is our angle. The adjacent is 8. So cosine of theta will give me 8 over, still over the hypotenuse, so we still have 10. And once again, it needs to be reduced to 4/5. And we're going to move the tangent down here. So the tangent of theta, because this is our reference angle, the opposite is 6 over the adjacent 8, which will reduce to 3/4. Okay, now these are called exact values. Remember, when we leave them in fractions or if we have radicals involved in the values. All right, and I believe in this whole section you will always stick with exact values. Yes, you will always have fractions, you will always have radicals. Don't use decimals. Those are not exact, those are estimates. Okay, so that's important to remember. All right, your book does a pretty good job of explaining it from there on out. If, just in case, here we had, let's look at one of the problems. We have a 2, we have a 1. We don't know what this is. Now, I'm not going to do the whole Pythagorean theorem for you again because I know you're capable of doing that. We would get the square root of 5. So now, since this is the hypotenuse, let's change it up here and let's make my theta up here. Okay, so since if we do that, if we change it, remember that's my new reference angle. So now this becomes the adjacent and this becomes the opposite. So for the sine, I'm going to have the opposite, which is 1, over the hypotenuse, which is the square root of 5. Now this is not a reduced radical, so we have to be careful. Remember, here we have to multiply by 1. We're applying the identity property and continue reducing square root of 5 over 5. So make sure you always reduce when necessary. Okay, if for some reason, I'm going to do one other idea, because sometimes they will simply tell you that the cosine of theta is equal to 3/4. Let's change that up. Let's make it a 3/5, okay? Now, if I know that the cosine of theta is equal to 3/5, and it wants me to tell you what the sine is and what the tangent is, I simply have to draw my own right triangle, and I have to think about cosine. Remember, cosine is adjacent over hypotenuse, so the 3 has to represent the adjacent, and the 5 has to represent the hypotenuse. So I can fill those in. If this is my theta, and I can pick whichever one I want to, then the adjacent will be here, the hypotenuse will be here, and then by using the Pythagorean theorem, I can once again determine that this is 4. So now I can go on and say that sine is opposite over hypotenuse, which is 4/5, and that tangent opposite over adjacent is 4/3. Okay, so sometimes it'll be given to you in this method. So we're doing the same thing every time, but it's given to us in kind of a different manner each time. So just watch what you're doing, think it through, apply your Pythagorean theorem. If you know 2 sides and you need a third, that's what you should do for sines, cosines, and tangents, remember, SOHCAHTOA. Okay, so that's going to finish it up for 8.2. You can watch a second video when you get ready for sections 8.3 and 8.4. Okay? I hope that that works. Again, contact me if it doesn't. Goodbye.